Imagine charging your car in just 9 minutes. Tesla's latest breakthrough might make that a reality. Can you imagine going from empty to full while making a coffee? Is this really possible, or is it just hype? And what does it mean for electric cars, long trips, and charging stations everywhere? How can one battery promise 1,000 miles of real-world range and production lines, hitting 34 gigawatt hours? Could this finally change everything we know about electric vehicles? What if you were getting into a Tesla and knowing you can drive 1,000 miles without stopping once? That's exactly what Elon Musk revealed with the new aluminum-ion battery. This isn't some theoretical claim on a test bench. It's real-world range, not just lab numbers. For anyone who's ever worried about long trips or constantly hunting for a charging point, this changes everything. Suddenly, cross-country drives or even week-long trips without charging are no longer a stretch of the imagination. So how is this even possible? The secret lies in the battery's chemistry. Unlike traditional lithium-ion cells, which move a single electron at a time, aluminum ions can carry multiple electrons with each cycle. This allows far more energy to flow through the same battery volume, meaning a standard-sized pack now delivers almost triple the range without adding extra weight. And that's important because more range usually meant bigger, heavier batteries. Not anymore. What makes it even more impressive is how stable this range is in real-world conditions. Cold weather, uphill drives, or running the AC on a hot day, all used to dramatically cut your EV's distance. With aluminum ion, the cells maintain efficiency between 92% and 95% even in temperatures that would cripple a standard lithium battery. That's why drivers in cold regions or areas with extreme climates can finally trust the advertised range. Tesla's engineers didn't just pack in energy, they designed the entire system to work together. Every module, every cooling line, every protective casing contributes to keeping energy dense and heat under control. It's like a perfectly choreographed orchestra where each cell hits the right note, making sure the car doesn't just go far, but goes far consistently, and the implications are huge. For fleet operators, delivery vehicles, and long-distance travelers, this means fewer stops, less downtime, and more productivity. For everyday drivers, it removes the constant anxiety of finding a charger mid-journey. The aluminum-ion battery doesn't just add miles, it adds freedom. But here's the kicker. This isn't just about a single car or a single trip. This battery is built for mass production, with Tesla's new lines capable of handling 34 gigawatt hours per year. That means millions of cars could soon enjoy this ultra-long range. And if the range is just the start, what else might this battery make possible? How fast can it charge? And what other limits can it push? That's where the next breakthrough comes in. What if you could charge a Tesla from empty to full in just 9 minutes? That's exactly what Elon Musk revealed with the new aluminum-ion battery. This isn't a prototype trick or a lab-only number. It's real, practical, and coming to production vehicles. Imagine rolling into a charging station and being back on the road faster than it takes to grab a coffee. Suddenly, the old wait times that made EVs inconvenient are almost gone. The secret behind this lightning-fast charge isn't magic. It's a combination of chemistry and engineering. Aluminum-ion cells allow electrons to move much more efficiently than lithium. Each ion can carry multiple electrons at once, meaning energy flows faster through the system without overheating. And that's crucial. Heat has always been the enemy of rapid charging. Push too much current into a lithium battery, and it starts to degrade or even becomes a fire risk. But aluminum ion handles high currents without the usual stress, keeping temperatures below 40 degrees Celsius even under a megawatt of input. That's like watching a high-performance athlete sprint without ever breaking a sweat. Tesla also redesigned the cooling system to make this possible. The new battery features 18,000 microcapillaries that circulate coolant evenly across every module. No hotspots, no sudden temperature spikes, just smooth, balanced energy transfer. Traditional fast charging tapers off after a while to protect the battery. With aluminum ion, the peak power stays high almost the entire charge cycle, which is why the full 0 to 100% charge happens in minutes instead of hours. This speed isn't just convenient, it changes how people can use electric vehicles. Long trips no longer require careful charging planning. Fleet operators and delivery services can keep vehicles running with minimal downtime, and everyday drivers can plan weekend trips or long commutes without worrying about stopping at every other charger along the way. It's an efficiency upgrade that affects the car, the driver, and even the infrastructure around it. Industry experts have been watching closely. Many competitors are still struggling to push lithium batteries past fast charge limits without compromising lifespan or safety. Tesla's approach, combining aluminum-ion chemistry and precision cooling, flips the usual trade-off on its head. Speed doesn't cost durability, and convenience doesn't sacrifice safety. But this is just one piece of the puzzle. If 9-minute charging and 1,000-mile range are already here, What does this mean for how Tesla plans to scale production? How will these batteries roll out globally? And how soon could every new Tesla be running on this technology? That's where the story gets even bigger, and it's exactly what comes next. What if your Tesla could take in massive amounts of energy without ever overheating? That's exactly what Elon Musk revealed with the new aluminum-ion battery. This isn't just about fast charging. It's about keeping the whole system cool, efficient, and balanced, even under extreme conditions. Imagine a battery that doesn't sweat under pressure, never slows down, and keeps delivering peak performance mile after mile. How did Tesla pull this off, and why does it matter more than ever? The core of this innovation lies in how the battery handles heat. In traditional lithium batteries, fast charging or heavy driving generates hotspots. Some cells heat up faster than others, which causes degradation, reduces efficiency, and shortens lifespan. With aluminum ion, Tesla designed the cells to distribute energy evenly. The result is almost perfect thermal uniformity. No hotspots, no sudden temperature spikes, just smooth energy flow across every module. Tesla's engineers took this a step further with a highly precise cooling network. Each battery pack is threaded with 18,000 microcapillaries, tiny channels that carry coolant evenly across every cell. It's like giving the battery its own circulatory system. Even when the battery is pushed to 1.2 megawatts of input power, the temperature rarely fluctuates more than a couple of degrees. That means faster charging, consistent power delivery, and far less wear over time. Why does this matter now? Because battery heat has always been the hidden limit of electric vehicles. It determines how fast you can charge, how far you can drive, and how long the pack lasts. Competitors are still struggling to find solutions that balance speed and longevity. Tesla's approach flips the equation. Efficiency and thermal stability aren't compromises. They're built-in advantages. The aluminum-ion chemistry itself plays a major role. Unlike lithium, aluminum ions move multiple electrons per cycle, which means energy moves faster without creating excess heat. Combine that with a sophisticated cooling system, and the pack can handle ultra-fast charging while maintaining optimal temperature. This isn't just safer, it means the car feels consistent day after day, year after year, whether it's a cold winter morning or a blazing summer afternoon. This thermal stability also opens the door to higher overall efficiency. Energy that would normally be lost to heat stays in the system, powering the car instead. It's why the 1,000-mile range and 9-minute full charge are even possible in real-world conditions. And if the battery can maintain that stability under intense use, what does this mean for long-term durability and daily driving reliability? Next, we'll look at how this stability feeds into the battery's longevity and life cycle, and why Tesla claims it could last far longer than any production EV battery before. Imagine a battery that could last longer than the car itself. That's what Elon Musk unveiled with Tesla's aluminum-ion technology. We've all seen EV batteries degrade over time, losing range, power, and reliability. But with this new chemistry, Tesla is promising something entirely different: years of consistent performance without the worry of replacements. How is that even possible? And what does it mean for daily drivers and fleet owners alike? The secret lies in the aluminum-ion chemistry itself. Unlike lithium, which slowly wears down due to repeated expansion, contraction, and dendrite formation, aluminum ions move multiple electrons without damaging the cell structure. Each cycle leaves the battery practically untouched at a microscopic level. That's why Tesla claims over 9,000 full charge cycles with more than 80% capacity retention, something unheard of in production EVs today. This isn't just lab talk. In real-world terms, it means that if someone charged their Tesla every day from 0 to full, the battery could still function efficiently for decades. For a regular driver, that translates to millions of miles of dependable range without ever worrying about degradation. Compare that to current lithium-ion batteries, which start losing efficiency within a few years, and the difference is staggering. What makes this even more impressive is that longevity doesn't come at the cost of performance. Some long-life batteries reduce power output to preserve cycles, but Tesla's aluminum-ion packs maintain peak performance throughout their lifespan. Drivers experience the same rapid acceleration, smooth energy delivery, and long-range reliability year after year. Experts in the industry are calling this a fundamental shift. If EV batteries no longer need replacement every 8 to 10 years, it drastically changes ownership costs, resale value, and even environmental impact. Fewer replacements mean less waste, lower costs for drivers, and a more sustainable approach to mass EV adoption. But there's more to this longevity story than just endurance. Tesla's design allows the battery to enter a second life once the vehicle reaches the end of its road use. It can be repurposed for home energy storage or grid support, maintaining high efficiency for years outside the car. Essentially, the battery keeps working long after the vehicle itself retires. So if this battery can last a lifetime on the road and then continue to serve as energy storage, how will it reshape the economics of electric vehicles? And more importantly, What does this mean for Tesla's ability to scale production without compromising quality? Next, we'll dive into the innovative production lines that make it all possible, how Tesla plans to build millions of these aluminum-ion batteries efficiently and at scale. Tesla didn't just change the chemistry, they rethought the entire battery from the ground up. Elon Musk revealed that the aluminum-ion battery isn't just about more energy or faster charging, it's about how every single cell is structured to work as a perfectly coordinated system. But what makes this architecture so special, and why does it matter for performance and safety? At the heart of it is a multi-layer design that combines ultra-thin aluminum anodes with a carbon-based cathode and a chloroaluminate ionic liquid electrolyte. Instead of relying on traditional bulk electrodes, Tesla created a system where electrons move faster, heat spreads evenly, and every cell communicates with the rest of the pack. It's almost like an orchestra where every instrument plays in perfect sync. No hotspots, no weak links, no wasted energy. Another key innovation is the honeycomb-shaped aluminum casing. This isn't just for looks. It strengthens the battery, improves cooling efficiency, and ensures that energy flows evenly across the pack. Even under extreme load, Tesla's system maintains uniform temperature and voltage across all cells. That's what allows the car to handle 1.2 megawatts of input without a single glitch. And then there's the micro-channeled cooling system, inspired by aerospace technology. Tiny capillaries run through the battery, circulating coolant with surgical precision. Each cell gets the exact amount of thermal management it needs, preventing overheating while keeping the system lightweight and compact. This level of control is unheard of in conventional EV batteries. The architecture also makes scaling production easier. By designing modular packs and standardized units, Tesla can replicate the setup across its gigafactories without losing efficiency or reliability. Every battery that comes off the line benefits from the same precise design principles, whether it's powering a Model 2 in Houston or a Model 3 in Nevada. What's fascinating is how all these elements, aluminum-ion chemistry, honeycomb casings, and micro-channel cooling, work together seamlessly. It's not just about raw numbers on paper, it's about a battery that delivers consistently under real-world conditions, from a short commute to a 1,000-mile trip. So the question is, how does Tesla take this precise, high-tech architecture and actually produce it at massive scale? That's where the next chapter comes in, revealing the 34 gigawatt-hour production lines that make this innovation a reality for millions of vehicles. Tesla didn't just stop at faster charging and clever architecture, they pushed the limits of energy density like never before. Elon Musk revealed that the new aluminum-ion battery achieves an energy density that far surpasses traditional lithium-ion cells, redefining what a battery can store in the same space. But what does this mean for drivers, and why is it such a big deal? Put simply, higher energy density means more power packed into the same size battery. Instead of making the pack bigger and heavier to increase range, Tesla's engineers engineered the chemistry and structure so each aluminum ion carries multiple electrons at once. The result? The same-sized battery that can now deliver 1,000 miles of real-world driving range without compromising on weight or vehicle performance. This breakthrough also has a huge impact on vehicle efficiency. Higher density means less energy loss during transfer, smoother acceleration, and reduced strain on the motor and electronics. The car doesn't just last longer on a charge, it performs better throughout its lifespan. Even in cold or hot climates, the battery keeps a stable output, making those long trips more predictable and stress-free. Experts are already noting that this level of energy density changes the rules for EV design. Automakers have long struggled with the trade-off between range, weight, and cost. Tesla has found a way to pack more energy without making the car heavier or more expensive, which is a critical advantage for both everyday drivers and fleet operators. It's also a game-changer for grid integration and secondary uses. Higher energy density means the same battery can later serve as home energy storage or support renewable energy systems without taking up extra space. The potential impact goes far beyond just the car. It's about reshaping how energy itself can be stored and used. The most exciting part? This isn't a lab prototype. Tesla's aluminum-ion battery is already designed for mass production, and the energy density breakthrough is fully compatible with the 34 gigawatt-hour production lines Musk unveiled. That means these batteries are ready to power millions of cars while keeping the efficiency and reliability intact. So, with energy density reaching unprecedented levels, the next question is, how exactly is Tesla achieving ultra-fast charging without sacrificing safety or lifespan? That's what we'll explore in the next chapter. Tesla isn't just talking about revolutionary batteries. They're ready to produce them at an unprecedented scale. Elon Musk revealed that the aluminum-ion battery will be supported by 34 gigawatt-hours production lines, designed to churn out millions of units without sacrificing quality. But why does this matter right now? And how does it affect the future of EVs? Scaling up production solves one of the biggest challenges in the EV world: supply bottlenecks. High-tech batteries are often limited by material availability, manufacturing speed, or complex assembly. Tesla's new lines are designed to handle aluminum-ion chemistry efficiently, using streamlined automated processes that reduce waste and speed up assembly. This isn't just theory. These are real-world, operational factories ready to deliver. The scale also impacts pricing and accessibility. By producing batteries in huge volumes, Tesla can lower the cost per kilowatt-hour, making longer-range EVs more affordable for everyday drivers. It's a clear step toward mass adoption, not just luxury or early adopter markets. Analysts suggest that having 34 gigawatt-hours lines could power hundreds of thousands of Model 2s annually, putting Tesla ahead in both technology and availability. Another key point is reliability at scale. Producing millions of units without quality issues is notoriously hard. Tesla's experience with gigafactories gives them a head start, ensuring each battery meets performance, safety, and longevity standards. This also sets a new benchmark for the industry, showing that high-performance aluminum-ion batteries aren't just possible, they can be produced efficiently at scale. And there's more. Large-scale production lines make it easier to support global energy initiatives. These batteries aren't just for cars. They can power home storage, commercial energy systems, and even support renewable grids. The 34 gigawatt-hours capacity gives Tesla the flexibility to integrate aluminum-ion technology across multiple markets simultaneously. So, with these scalable lines ready to roll, the next question is, how do these batteries handle ultra-fast 9-minute full charges without overheating or degrading? That's what we'll dive into in the next chapter. When it comes to EVs, one of the biggest real-world concerns is how batteries perform in extreme conditions. Cold winters can sap range, while scorching summers can overheat cells and slow charging. But Tesla's aluminum-ion battery is designed to handle it all. Elon Musk revealed that these batteries maintain performance in a wide temperature range, from freezing minus 50 degrees Celsius up to 80 degrees Celsius without needing complex thermal management systems. Why does this matter? In traditional lithium-ion batteries, cold temperatures slow chemical reactions, reducing range by 20 to 40% in some cases. Owners often have to preheat the car or accept shorter drives. Aluminum-ion batteries don't have this problem. They deliver consistent power no matter the weather, meaning your car is ready to go, whether you're navigating icy streets in Montreal or hitting summer highways in Phoenix. Durability in real-world driving is another major factor. Long trips, stop-and-go city traffic, and frequent fast charging can all degrade standard batteries over time. Tesla's new chemistry is resistant to degradation, maintaining performance across thousands of cycles even under daily driving stress. This makes it not just a lab breakthrough, but a reliable choice for everyday use. Experts are already noting that this combination of cold weather resilience and real-world reliability could set a new standard for EV ownership. Fleets, delivery vehicles, and commuters can now plan routes and charge stops without worrying about range drops or unexpected downtime. It also reduces long-term maintenance costs because the battery is less prone to stress-related failures. And here's the kicker. This reliability doesn't compromise speed or efficiency. Even in freezing conditions, the battery can still support ultra-fast 9-minute full charges and 1,000-mile ranges, making winter road trips far more practical than ever before. So, with aluminum-ion batteries proving themselves in extreme temperatures and everyday driving, the next big focus is how this technology could impact global EV adoption and Tesla's new mega production plans. That's what we'll explore in the final chapter. Tesla's aluminum-ion battery isn't just a new type of battery, it's a potential shift for the entire EV industry. Elon Musk revealed that with 9-minute full charges, real-world 1,000-mile ranges, and massive 34 gigawatt-hour production lines, this tech could make electric vehicles faster, cheaper, and more practical for everyone. Think about it. Lower costs, longer lifespan, extreme temperature reliability, and ultra-fast charging all rolled into a scalable solution. This doesn't just help Tesla, it sets a new benchmark for competitors, forcing the industry to rethink how EVs are built, powered, and priced. For consumers, it means affordable long-range EVs without compromises, whether for daily commutes, road trips, or fleet operations. The implications go beyond cars. With these high-capacity batteries, home energy storage, renewable integration, and even vehicle-to-grid systems become more feasible, supporting a greener and more reliable energy future. Aluminum-ion technology could reshape everything from EV ownership costs to global energy security, reducing dependence on lithium and making electric mobility more accessible worldwide. As Tesla ramps up production in its massive new lines, these batteries aren't just concepts, they're ready for real roads and real drivers. And while other companies are still exploring incremental improvements, Tesla is pushing the envelope with speed, scale, and reliability all at once. So the big picture is clear. This isn't just a battery innovation. It's a redefinition of what an EV can do, how far it can go, and how practical it can be for everyday life. The question now isn't whether aluminum-ion batteries will succeed. It's how quickly they will transform the way the world drives and stores energy. From ultra-fast charging to extreme reliability, long lifespan, and massive production, Tesla's aluminum-ion battery promises to change the game, and the future of electric vehicles is arriving sooner than anyone expected.